Okay, here we go. Let's get started. First thing, let's do a warm-up. What does 3 represent for this graph? What is the equation of the midline? And what is the period of the graph? So take a second to visualize, look at this, think about your different transformations, what makes a complete cycle, and answer these 3 questions. So hopefully you decided that the amplitude is representative of 3, since it's going 3 up and then 3 down. The midline is at y equals 1 because that's where your x-intercepts are at this line here. And then the period of the graph, so what makes a full complete cycle? So if I were to start here, go up a cycle, down part of that cycle, it's 2 pi. Let's try a different example. Okay, identify the errors of the equation as it should represent the graph pictured below. So I'm saying the equation is y equals 2 times the sine of 1/2 x plus 2 pi plus 3. So based on the information that I give you, that the phase shift is 2 pi, the vertical shift is 2, the period is 4 pi, and the amplitude is 3, what's wrong with my equation? What did I mix up here? So you should have seen that I switched around the amplitude and vertical shift. And the reason I did that, because that's a big mistake that a lot of people think about. They think that the first number is the vertical shift and the last number is the amplitude, but that's actually not the case here. And then another important thing is I'm moving to the right for my phase shift. The phase shift is going this direction. So remember, it has to be opposite. So it should really say y equals 3 times the sine of 1/2 x minus 2 pi plus 2. So today we're going to get into, given these equations, how can I now go ahead and write an equation based on my graph? So there's a few steps that we're going to go through. So if you have that notes reference sheet, I would suggest pulling that out and writing these things down. Or if you don't, make sure you have scrap paper and list these steps down as we go through them in the video. So here we go. So anytime that you want to write an equation, you're either going to be given 2 points or you're going to be given a graph in which you have to find those 2 points. So your first step, no matter what, is you want to label a maximum and a minimum on the graph. So they have to be consecutive maximums and minimums. So what I mean by that is you don't want to choose a maximum, go another period later, and choose a minimum. You want to choose either a maximum with the following minimum or a minimum with the following maximum. It's up to you. There is going to be a difference depending on what order you choose, and that's what happens when I get to that little note at the bottom of the page where you see max and min, positive amplitude versus negative amplitude. So just keep that in mind. So your first step, whenever you get these 2 points, is you want to determine your vertical shift, because that's your new midline. So if you think about it, if I have a maximum average point here, because remember your amplitude has to be exactly halfway up and then halfway down. So in other words, to get your K or your vertical shift, you're just taking the average of your y values, because remember, a vertical shift, you're either going up and down, so that's only affecting your y values. So you would take your y max value plus your y min value and then divide that by 2 to get your average. That's how you get your vertical shift. So that kind of leads into the amplitude. Remember, that's your deviation from your midline. Your midline is your new axis here. So you need to be exactly halfway from your midline to either your maximum and also to your minimum. So to get that, you would actually take your maximum y value, subtract your minimum y value, divide that by 2, and you want the absolute value. Remember, you want the absolute value because amplitudes always have to be written positively. If they are negative, you just say that it's the positive version of the negative. So that's how you get the amplitude. Your next step is you want to determine the period. So when you're determining the period, you're going to take 2 times your x max value minus your x min value. If you think about it, say we have a sine graph, so we have something like this. So I have my maximum here, and then I have my minimum here. If I subtract this distance here, and then I multiply it by 2, I'm going to have my entire period work, because that distance here will also be equivalent to that and that added together. I know it might be a little bit hard to visualize, but that is how it works. It's essentially halfway between them. It's a little bit easier to visualize on a cosine graph because if you think about it, a max to a min is exactly halfway through what you're doing, and then you're just multiplying by 2. So once you have that period, you're able to find your frequency using that peanut butter pie analogy. B times B equals 2 pi, peanut butter pie. So then lastly, we've done everything except for the phase shift. Well, the phase shift, remember, that's your new starting point. So for sine, you have to do a little bit of an adjustment. You're going to actually take your max x value and your min x values, whatever the x coordinate is that. You're going to add them together, so x max plus x min, and you're going to divide that number by 2. The reason you're doing that is, if you think about it, what you're getting when you take the average of those points is you're getting the one right in between. So you're getting that as your starting point. Now, if you notice, for a sine function, you can actually start at any intercept here. But depending on what max and min you choose, it's going to vary. So if I'm starting here, then this is my phase shift there. For cosine, it's actually really convenient. You just take the x value of your maximum. Because if you think about it, remember over here, you always start a cosine graph at a maximum. Well, if you already have the coordinate of your maximum, then you're just going to shift it over to that x value. And then your last step is to bring it all together and write your equations. Obviously, these two equations are going to be very similar. All it's going to change is your h value because your shift will be different. So this kind of leads into a positive amplitude versus a negative amplitude. If I choose my max here and my min here, I'm finding that average value here. So if I'm saying that my graph is starting here, well then to get one full cycle, I would be going down first and then up. So if I'm going down first, remember your graph is flipped. So just when you're writing your equation, make sure you have a negative, and then if there's a number with it, you put a number there, and then sine, cosine, or sorry, it would just be with sine. This is only with sine. Likewise, if you choose then a minimum before a maximum, well, the average value that you're getting is going to be right here. So then that's going to be normal. It's just going to be positive amplitude because if you think about it, you're going to be starting here and then one full cycle goes like that. So that's the only thing to keep in mind. If you ever have that, please, please, please be on the lookout if your maximum comes first or your minimum comes first. So that's why if you're given 2 points, try to draw a quick little sketch so you can see what comes first. Like if you're given, I don't know, 1, 1, and then you might be given 3, 1, 2, 3, 4. 3, 4. Well, your minimum is going to come first, so then you can start with a positive amplitude at time. So that's what I mean by just a quick little sketch. It doesn't have to be anything pretty. Just like that. Okay, so again, now that we just spent all that time graphing, given an equation, you now have all the steps that we took down when we want to actually now write our equation after watching this segment of the video. So again, if you do not have these steps written down, please do not go any further, otherwise you will be very, very lost. Okay, so before we get into going through the process again, I just want to reiterate the fact that we can have several different equations that represent one graph. That's where my negative amplitude versus a positive amplitude piece kind of comes into play. If we are writing a sine equation, we can start our equation at any intercept of our choosing. And curves go on forever and ever, meaning we have an infinite number of ways we can write an equation. Same thing for a cosine. If I continuously start at a max, you can shift it to any max. You could also honestly shift it to any minimum, but then make your amplitude negative. So as you're writing your equations, if you are doing one slightly differently from the way that I have it, or slightly differently from the way somebody else has it, that is okay. It is most likely right. The only thing that will be affecting is your phase shift and potentially your amplitude. So here's an example of one where I wrote out all the work for you, so I'll quickly go through it, and then obviously if you need to pause and continue looking at it more, please by all means do so. So I'm giving you that the max is 1,7 and the minimum is 3,3. So the first thing I do is I draw a sketch, and the reason I'm drawing a sketch is because I need to know if I'm going to have to make my amplitude positive or if I'm going to have to make it negative. So just by looking here, if I'm going to start here, I know that when I write my final equation, it's going to be negative because I'm going down first. So that's why eventually when we get all the way down here, you'll see that's going to be negative. So I start by finding my vertical shift. So I take the average of my y values, 7 and 3, which is 10, divide them by 2, I get 5. That's my k value. Next up is my a value. So instead of adding my y values, I'm now going to subtract my y values. So 7 minus 3 is 4. Absolute value of 4 is 4. 4 divided by 2 is 2. Then I need to find my period. So now I'm back to using my x value. So again, think about what is affecting. Is it the y values that are being affected or the x values? Period represents time, and time is our x. So I subtract my x value. So in this case, it's 1 minus 3, which is a negative 2, and the absolute value is negative 2 is positive 2, and 2 times 2 is 4. So if my period is 4, I can now find my frequency. So 4 times b equals 2 pi. I divide both sides by 4, and obviously 2 over 4 simplified is 1/2. So my frequency is now going to be pi halves. So now we get into the hardest part, our phase shift. It's very easy for cosine. I literally just take my x value of my maximum, which is 1. And because it's shifted to the right one, it's going to wind up being a negative when I actually write my equation. Here, for sine, I'm adding my two x values, so 1 plus 3 is 4. 4 divided by 2 is a 2. Now, because I know that my 2 is a positive number, that means I'm technically shifting to the right, so make sure you write it as a negative as your answer. So my final equations are y equals negative 2 sine of pi halves times x minus 2 plus 5. And then it is y equals 2 times cosine pi halves of x minus 1 plus 5. Sorry that got a little bit cut off there. But please again note that there are many possible situations. I also gave you a graphical kind of breakdown of this so you can kind of see what's going on here. My amplitude is a equals 2, and then I shifted up 5 units so you can see where I drew my dotted lines. My period from my max to my second max is 4 units, so just take a look, pause that video, and just try to soak this information in a little bit more. It might take a few reads, and then go ahead to the next one. So pause it, please, and read it over one more time. Okay, here's one more example. So this time I'm giving you a graph, and we are identifying first our max and our minimum value. First thing you should note is that my x-axis is very sparsely labeled, so you kind of have to figure out what are the different units that I'm going by on this graph. So you should see that there are a total of 1, 2, 3, 4, 5, 6 blocks get you to pi. So that means there are 6 pi over 6 blocks. So each of these represents 1 pi over 6. So that's kind of how I get my max and my min here. So I'm obviously counting 1 pi over 6 is my max x value. So then 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6 will be my minimum value. So now that I have my coordinates for my max and my min, I can go ahead and start going through the different steps to do this. So my first is finding my k value. Well, I have my 4 and a negative 4, so when I add them together, that is 0. 0 divided by anything will always be 0, so there is no vertical shift here. Then, I want to find my a value, so now I'm subtracting my two y values. So 4 minus a negative 4 is a positive 8 divided by 2 is 4. Then I'm finding my period, so I'm subtracting my x values on my max and my min, which gives me a negative 6 pi over 6, and you should realize that the 6's cancel, and then obviously because its absolute value becomes a positive pi, so we now have 2 pi is our period. So ding ding ding, you should be saying, wait a second, 2 pi is my normal period for a parent graph. So then this should be very easy to find your frequency, because if 2 pi times b equals 2 pi, b has to be 1, so our frequency is 1. Last but not least, we want to find our phase shift. So for cosine, my maximum, that's where I shift to, so I'm at pi over 6, and because it's positive, it's going to wind up being negative in the equation. And then for my sine, I have to do a little bit of math here. So I'm adding and subtracting pi over 6 plus 7 pi over 6, which gives me 8 pi over 6, which really simplifies to 4 pi over 3. And then I am dividing by 2, so I'm really multiplying by 1/2, and that's going to simplify to 2 pi over 3. If you have a little bit of trouble seeing that, because this is the graph here, it's kind of nice that you can actually go back to it, because remember, you're finding the intercept here, so you could also just count over and be like 1, 2, 3, 4 pi over 6, and 4 pi over 6 simplified is really 2 pi over 3. So that might help you out a little bit as well, seeing that there. One more thing, because I am starting here, I know that my amplitude has to be negative for sine, because instead of going up, I am now going down. So when I see these equations here, that's why you'll see the negative written here. So it's y equals 4 cosine of 1 times x minus pi 6, because there's no vertical shift, and then y equals negative 4 times sine, or sorry, negative 4 sine of 1 times x minus 2 pi over 3. So now that you've seen a few examples, it's your turn to practice these. So on Google Classroom, there's a worksheet. I give you the graph for a few of them, and then if you keep going, you just have the max and the min values. So I tried to summarize the steps in a little bit more shorthand notation. Please make sure you know these steps. You will need to memorize them because you are not using them on the test. Come to memorize them. Okay? All right. Good luck.